This is a short video on using calculus applications in economics. Specifically, in this video, we're going to be looking at the use of calculus in analyzing production. And in this case, we're looking at a short-run production curve and the use of calculus to find two specific points of interest to economists: the point of diminishing returns and the point of negative returns. Now, it's important to recognize that when we talk about production, that economists think about production in both terms of long-run and short-run production decisions. This video is focusing on short-run production decisions. Specifically, when economists mean short-run production decisions, what they're talking about is when the quantity produced is a function of the labor and the capital involved in production, but the amount of capital used in the production process is fixed. Hence the little line over it. Now, a production function can be drawn out graphically, as it is right here, where we've overlaid a graph that has the independent variable labor and the dependent variable, the quantity we produce. In the production function in the short run, there are two key elements of what economists are looking for. One is the point of negative returns. This is the point where production is at its highest point, where adding additional workers would actually cause the amount of production to go down. This is because the amount of available capital has been fully utilized. So you're just overusing the capital to the point where workers will only get in each other's ways if you go beyond this point. Hence, production goes down. The other point is the point of diminishing returns on capital, or the point of diminishing marginal returns on capital. And this is the point where, as we add additional workers, at first adding additional workers causes the total amount produced to go up, but go up at an increasing rate. Each subsequent worker adds more to the total product than the previous worker. Once you pass the point of diminishing returns, adding each additional worker, well, it still adds to the total product, but at a lesser and lesser and lesser amount. Each additional worker brings somewhat less additional product to the production function. Now, this can be looked at graphically. It can also be looked at mathematically. This mathematical equation here basically reflects the shape of this curve. Now, using an application of calculus, we can take this equation and we can modify or change the equation to get different variations of the equation and then solve that equation to get both the point of negative returns and the point of diminishing marginal returns. This is how we do it. Basically, this equation is my total production function. It's a short-run production function because I only have variables of changing labor. I have no capital option here. In this case, what I want to do is I want to find out the place where my marginal product is 0. That is, adding an additional worker will yield no additional total product. If you look at this graph, at the top of my total product function, when I'm at my point of negative returns, the slope of this curve is 0. What I want to look for mathematically is the place where adding an additional worker will yield no additional total product. That's what this mathematical notation means. Adding an additional worker, a change in labor, has no effect on total product. That is the top of my total product function. Now, to figure this out mathematically, I use a calculus rule called the power rule. It's a very simple rule. All I do is I take the exponent, bring it down, multiply it by the number in front, and subtract 1 from the exponent. In this case, the 2 comes down. We have an 84. L. This is really L to the 1 because it's 2 minus 1. And L to the 1 is just L. Minus 3 comes down multiplied by 4. 12. And then L, 3 minus 1, is 2. So what I've done is I've modified my equation to find the first derivative of my total product function. Now, what I can do from here is I can simply solve as it is. Change in total product, change in L equals 0. I can factor a 12L out of both of these. So that will give me 12L. This will give me a 7 minus L. Now, this gives me basically two options to look at. One is, when L equals 0, my change in labor will yield no total product. I kind of know that intuitively. After all, when I have 0 workers, my company is not producing anything. What I'm really interested in is this internal piece. What I'm interested in is seeing that 7 minus L. Basically, I can do 7 minus L equals 0, which will lead me to a situation where L equals 7. What this tells me is that my point of negative returns right here, the point where my total product is maximum, that is the point where I have 7 workers. In other words, I should never have more than 7 workers working for my company because I will just end up actually producing less. The reason why I'm producing less is because I'm overusing my fixed amount of capital. The second thing I want to find is my point of diminishing returns. This is this inflection point. This is when I go from having my worker who, as I hire them, adds the largest amount to marginal product to when I hire my next worker and my next worker produces a slightly less amount of marginal product. It is a point of change or a point of inflection. To find this, I have to find the second derivative. The way to see this is that this curve here, change in total product over change in labor, this is really my marginal product curve. If I want to find this inflection point, what I need to do is take the second derivative. That is, find where a change in my marginal product for a change in labor is 0. Where adding an additional worker will yield no additional marginal product. Just the way I did the power rule to get from this equation to this equation, I will use a power rule on my marginal product curve to get to my second derivative down here. Same basic rule. This is L to the 1. It simply becomes 84. 2L becomes 24. 24, L to the 1, which is just L0. So, what I do from here, I solve for 0. Remember that there's a 7 factor I could take out here, right? Oh, sorry, there's a 12 factor I could take out here. So what I could get is 0 equals, pull out my 12, this would give me 7 minus 2L, which could then, all I care about is this internal piece here, right? This will give me an L of 3 and 1/2. Now what this tells me is that my point of diminishing returns is somewhere between my third and my fourth worker, okay? And so what this video is meant to show is that I can use calculus to take this mathematical equation and reduce it down to the key pieces that I want to know in terms of finding out my production function, namely my point of negative returns by getting the first derivative and my point of diminishing marginal returns by taking the second derivative.